Okay, so we are in Chapter 2, Section 4 for IM 3, called Writing Linear Equations. So for this one, we're going to review some of the forms that we can put our linear equations in. We have slope-intercept form, and the equation of a line where m is the slope and b is the y-intercept, and it's written like this, y equals mx plus b. So we have slope, and we have y-intercept. And I know I said this on the last section, so if you hadn't watched that one, you can also think of this as the change. If you're looking at a word problem, what is it changing by? And this guy is the starting point. So it's just kind of an easy way to refer to these when you're looking at a word problem. Point slope form of an equation of a line is the equation of a line where x1 and y1 are the coordinates of a point, so just 1 point, and the line, 1 point on the line, and m is the slope of the line. So here we have the equation y minus y1 equals m times the difference of x minus x1, or x and x1, I should say. So again, we have slope. And this time, instead of we're not given the y-intercept, we're given a point. So we're given a point, which is x1, y1. So we have y and x in here, just like we have y and x in this situation, or in this form. So both of them have y and x in them, just depends on the format, or what we're given. If we're given slope and y-intercept, this is the easier one to use. If we're given a point and a slope, or 2 points, this is the easier form to use, because if we're given 2 points, we can pretty easily calculate slope and then plug it in here. So again, just depends on the situation and what we're given. Let's scooch down because we're going to look at parallel versus perpendicular lines really quick. So parallel and perpendicular lines can be determined by the slope. Parallel lines have the same slope. And lines that are perpendicular have a product of slopes that is -1. Or you can think of them as negative reciprocals. So they give us an example down here. They say the original slope is 2. If it's parallel, it would also have a slope of 2. If it's perpendicular, its slope would be -1/2. So remember, this is 2 over 1. What they did was they flipped it over. It's reciprocal, and it changed signs. So when I say negative reciprocal, I don't necessarily mean it's going to be negative. In this case, it is. But if it started as a negative, then it would flip signs to a positive. So it just means you're flipping the signs when I say negative reciprocal. And reciprocal means you're flipping it over. All right, let's go ahead and take a look at the next page here. Scooch down. All right, so it says, write an equation in slope-intercept form for the line described. So be careful with this. If you write the wrong form on Alex, you may have the equation right in that form, but if it's not on the form that it's asking you to write, it'll mark you wrong. So make sure you're writing it in the correct format. All right, so this gives us a slope. Remember, that's our m. It tells us passing through this point. So this is x1, y1. So it's giving us a point. So we have to plug it into point slope first. So we have, and remember, we're using this guy here, so we're doing the y's first. Y minus y1, which is 2, equals m times x minus x1, which is 0. So now if I do x minus 0, I just get x, so I have y minus 2 equals 3. And it would be times x in here, because I would have just the parentheses x. So I'm just going to drop the parentheses here and write x, like that. Oops, I said I was going to drop the parentheses and then I wrote them anyway. Got myself distracted with my pen here. And if I want it in slope-intercept form, remember that's y equals mx plus b. So I need to add 2 to both sides because I need this y to be by itself. 3x plus 2. So remember, y minus 2 equals 3x. That is an equation of the line. It's not really in either of the two form. Well, it is actually in point slope form because the 0 eliminated down. But it wants it in slope-intercept form. So just be careful with the directions there. All right, we're going to do the same thing on this one. We have a slope of 4, and we're given a point. So we're going to plug it into point slope, and then we're going to turn it into slope-intercept. So y minus y1 equals m times x minus x1. All right, this one doesn't cancel out kind of nicely like the other one did. So we need to distribute this 4. So we have y minus 9 equals 4x minus 24. And now we can add the 9 over to the side. Remember, we just want y by itself. That's how we get y equals, right? So we don't necessarily need to move anything over to this side. We just need to move that 9 away. So y equals, because these guys cancel, we have 4x, and we're negative, positive, so we're subtracting. Bigger number decides our sign there. So let's see, we end up with 15. All right, so that is our equation in slope-intercept. Now we're given 2 points. So again, we're going to use point slope, but first I need to know what the slope is. Remember, the slope is the difference or the change in y's over the change in x. So my m is going to be y2 minus y1 over x2 minus x1. And if you notice, I did 2 negatives here. The minus is part of the formula. I don't get to get rid of that. So if it's a negative number, I have to put 2 negatives. Minus negative gives us a positive. All right, now I'm going to work this out. So I have 10 minus 5, I get 5. Negative 3 plus 8, I get 5. So I actually end up with 1 over 1, or just 1 for my slope. So my slope is 1. For my point, when I'm working in point slope, when they give you 2 points, you get to choose one. Doesn't matter which one you choose. You can write the equation with this point. You can write the equation with the other point. It truly does not matter. Both of them will be correct. So I'll show you both of them, just so that we can see really quick. So I'm going to use this one first, and then we'll come over to this one. So you don't have to do both. I want to make that clear. You choose one or the other. But it'll actually give you the same equation when we work it out here. So we have y minus y1 equals m times x minus x1. Again, 2 negatives there. So this 1 doesn't really do anything. Even if I distribute it, nothing happens there. So y minus 5 equals x plus 8, because 2 negatives make a positive. I'm going to add 5 to both sides here. So I get y by itself. Remember, we're still looking for slope-intercept form. Don't forget to put it in the right form. Otherwise, yes, we have it in point slope form, but it will get marked wrong because you didn't follow the directions. All right, so this would be 13 plus 13. All right, I'm going to switch it over, and I'm going to use red for this, just so you can see, again, you don't have to do both of these. But if I have y minus y1 equals m times x minus x1, in this case it's negative 3. So now again, that 1 doesn't mean anything. It's going to be y minus 10 equals x plus 3. I'm going to add 10 to both sides. And these cancel. Y equals x plus 13. Look at that. Aren't they identical? So it doesn't matter which point I use. I will come to the same equation. Now in point slope, they don't look the same. The numbers do still look different. But once I translate them, or manipulate it down a little bit into slope-intercept, I can see that they are exactly the same equation. All right. Next piece. So now we have it passes through 4 and negative 10. I'm going to go back to my blue. I like my blue a little better. So here's my point, and then it's parallel to this equation here. Well, why are they telling us that? Remember, on this page, if it's parallel, it has the same slope. So they did tell us that. All they want us to do here is grab the slope. Remember, that's always next to the x. So this is our m. So they're giving us this entire equation just so that we can grab that slope. So now we're going to plug it in. Y minus y1 equals our slope, which is 7/8, times x minus x1, which is 4. All right. Minus negative, this is going to turn into a positive. 7/8, I get. So I'm going to turn this one into a positive, and I'm going to do this next step. We want to distribute this 7/8. So I have 7/8x, and that just sandwiches together because it's multiplication, minus, and I'm going to show you this off to the side here, just to, so it's times -4. Remember, there's a 1 on the bottom. I can cross cancel here, or I could simply multiply across the top. I get -28 over 8, and then I could reduce. But I could reduce first. We're in I'm 3. We should definitely be able to see this. 8 can divide by 4 twice. 4 can divide by 4 once. So now I have 7 times -1, and that's -7. 2 times 1 is 2. So I can kind of quickly reduce that so that I don't have to deal with it so much. So let's go -7/2. Sorry, I was confusing myself with the negative. I'd already put it there. So now to put it in slope-intercept form, I just have to subtract 10 from both sides. Y equals 7/8x. And now to do this, I need to go minus 10 means, remember if I want to subtract it from a half, I need to say how many halves are there. There's 20 halves to turn into a fraction. So if I combine this, I have minus 27 halves. Alex may be okay with this. A lot of the time we're perfectly fine with putting in fractions. It's usually not too picky about this when we're doing equations. It may very well ask you to make it kind of a proper fraction, but I don't know how picky it would be with that. So just make sure you're paying attention. It should pop up with some warnings on there too if it doesn't like that format. But that should be, about as crazy as it gets. It just might give you a warning there that it's not simplified. All right, let me scooch up, and I think, is this the last one here? It is the last one here. All right, so this one, we have a point, and it's perpendicular to this one. So we still want to grab this number, but it's not the same as, parallel is the same as. Perpendicular means that I need to flip it over and flip the sign. So this is my slope. So be careful between the words parallel and perpendicular because, it does change your problem and what you're going to plug in here. All right, so now I have y minus y1 equals my slope, which is 3/5, times x minus x1, which is -9 here. All right, so let's go ahead and work this out. I'm going to deal with these negative signs real quick. 2 negatives, so they turn into positives. Now we can distribute this fraction here. So we need 3/5 x, because I'm multiplying by 3/5. I'm going to multiply here. So 3/5 times 9. I can't reduce anything. I'm just going to multiply across the top. That's going to give you 27, and I'm going to multiply across the bottom. It's going to give me 5. So I'm going to have plus 27/5. All right, now I'm going to subtract 3 from both sides. These guys cancel, and I end up with y equals 3/5 x plus, now if I want to do 3, remember that means 3 whole pieces, and each piece has 5 in it. So that's minus 15/5. So that's, just keep in mind, that's kind of going over there like that. All right. Lots of fun arrows going back here. So I put this one over here, and I was just showing you, I'm working it out on this side over here. I have more room over there. So now we can subtract, and let's see, what do we have? 5, 10, 12, right? 12/5. Just like that. So I'm pretty sure that is as far as they want us to go there. I was going to look and see. Sometimes the examples in the book are identical to the examples we chose for this, but I don't know if they are in this case. They are not quite the same, but that's all right. So they should, again, let you leave it just like this. That should be fine. If anything, they might want you to write the decimal, which would be 2.4 if we actually did 12 divided by 5, because that might be a little easier to graph than 12/5. So I can definitely picture where 2.4 would be. 12/5 might take me a few more minutes, to actually picture where it is. So anyway, that was the end of the section. I will see you in the next section here.